Good morning, students. I hope today it is audible clearly.
Yes, ma'am.
Yes, okay. Okay, we will start with the class. Good morning, everyone. So yesterday we have started with thermodynamics. So in the thermodynamics, synopsis part and complete ಮಾಡಿದೀವಿ, and we have discussed the first law, second law. Then we have also completed Carnot engine, right? Synopsis, we have discussed everything, and some of the questions also we have discussed based on that is the isothermal process, and some questions we have covered from the adiabatic process. ಹೌದಾ, ನಾವೀಗ ಫಸ್ಟ್ ಲಾ ಆಫ್ ಥರ್ಮೋಡೈನಾಮಿಕ್ಸ್ ಮೇಲೆ ಕೆಲವೊಂದು ಕ್ವಶನ್ಸ್ ಅನ್ನ ನೋಡೋಣ. ಓಕೆ, ಸೊ ಲೆಟ್ ಅಸ್ ಸ್ಟಾರ್ಟ್ ದ ಕ್ಲಾಸ್. So here is your first question for today's class, that is, a system performs work delta W when an amount of heat delta Q added to the system. The corresponding change in the internal energy is delta U, a unique function of the initial and final states, irrespective of the modes of change is. So ಏನಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಇಲ್ಲಿ? So here the work done is W,
Option.
delta W. Okay, option A, delta Q. Yes, it is correct. So here the work done is delta W. When an amount of delta Q is added to that, the corresponding change in the internal energy is delta U, a unique function of initial and final state. It is what? Delta Q. Antandre heat, delta Q. Heat is the unique function in the initial and the final state. Okay. Then the next question is, container of volume 1 meter cube is divided into two equal compartments by partition. Okay, so you have a container of volume 1 meter cube. It is divided into two equal compartments by a partition. Yes. One of these compartments contains an ideal gas. So at the other partition only one part allenide ideal gas ide. This is at a temperature of 300 Kelvin. The other compartment is vacuum. So ಒಂದರಲ್ಲಿ ideal gas ಇದ್ರೆ ಮತ್ತೊಂದು vacuum. The whole system is thermally isolated. So whole system ಅನ್ನ ನಾವು thermally isolate ಮಾಡ್ತಾ ಇದ್ದೀವಿ from its surrounding. The partition is removed and the gas expands to occupy the whole volume of the container. Its temperature now would be. Yes, so let us solve this one. Okay, so here first what they are saying according to the question, try to draw the diagram.
Option
That
C,
is, we
200.
have
Option C, ma'am.
Option C, 200K.
200K. So it is coming 200 or 300?
200.
200.
300, ma'am.
Yes, it will come 300. Will come 300. So see here, that is when the partition is removed, here the gas is expanding freely. According to the first law of thermodynamics, dq is equal to du plus dw. dq is equal to du plus dw. How that? So dq is thermally isolated system irodrinda. So our dq value is 0, which is equal to w is also 0. Why? Because the free expansion. Because of the free expansion, this dw is here. Therefore, we will get du is equal to 0. Yes, du is equal to 0 we are getting, which means that, so the differentiation of internal energy is 0 means, therefore the u is constant. U is constant here. Yes, but we know that the internal energy is the function of temperature. It is the function of temperature. Therefore, when it is the function of the temperature here, as the T is constant, therefore T is equal to how much it will remain? It will remain 300 Kelvin. So this is the solution of your answer. It is 300, option A. So let us go for the next question. Okay, the next question is, so this one you can try, that is by using first law of thermodynamics. 110 joule of heat, Q value kottidare 110 anta, added to a gaseous system whose internal energy change is 40 joules, then the amount of external work done is. So W you need to calculate, DW calculate madbekide, Q kottidare, delta Q kottidare, change in internal energy 40 anta ide. It is
Option B, ma'am.
yes. So it is option B, 70 joules. It is option B, 70 joules. Okay. I hope there is no any doubt in this question. It is dq is equal to du plus dw. We require dw is equal to, so 110 minus 40, that is 70 is the answer. Next question. Which of the following is not thermodynamical function? So thermodynamical function antandre, it should be a thermodynamic variable. Hoda. So enthalpy, work done, Gibbs energy, internal energy.
Option B, work done.
Yes,
Work
option
done.
B, work. Yes, yes, very good. So option B, work done is what? It is not the thermodynamic function. Option B, thermodynamic function alla. That is work done. The next question. When the amount of work is 333 calorie and the change in the internal energy is 167 calorie, then the heat supplied is. So again, the first law of thermodynamics formula we are using here. ಇಲ್ಲಿ ನೋಡಿ ಕ್ಯಾಲೋರಿಯಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಸೊ ಆನ್ಸರ್ಸ್ ನಮ್ದು ಕ್ಯಾಲೋರಿಯಲ್ಲಿ ಇರೋದ್ರಿಂದ ನೋ ನೀಡ್ ಟು ಕನ್ವರ್ಟ್ ದಟ್ ಆಯ್ತಾ. ಸೊ ಇಫ್ ಇಟ್ ಇಸ್ ಆಪ್ಷನ್ಸ್ ಆರ್ ಗಿವನ್ ಇನ್ ಜೂಲ್ಸ್, ಆಪ್ಷನ್ಸ್ ಏನಾದ್ರು ಜೂಲ್ಸ್ ಅಲ್ಲಿ ಇದ್ರೆ ನಾವಿಲ್ಲಿ 4.2 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. ಬಟ್ ಎಲ್ಲಾನು ಕ್ಯಾಲೋರಿಯಲ್ಲಿ ಇರೋದ್ರಿಂದ ನೋ ನೀಡ್ ಆಫ್ ಎನಿ ಕನ್ವರ್ಷನ್, ನಾವಿಲ್ಲಿ ಡೈರೆಕ್ಟ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದಾಗಿದೆ. ಸೊ ದಟ್ ಇಸ್ ಗಿವನ್ ಬೈ, so according to the equation it is dq is equal to du plus dw. Okay, so this is equal to 167 is the internal energy and the work done is 333. Therefore, so the answer is how much? Yes, 500.
Option C.
Option C, 500 is the answer. Option C, 500 calorie. Yes, let us go for the next question. Okay, the first law of thermodynamics states that, so first law of thermodynamics ಏನನ್ನ define ಮಾಡುತ್ತೆ? That is, system can do work, system has temperature, system has pressure, heat is a form of energy. So ಏನ್ define ಮಾಡುತ್ತೆ first law of thermodynamics?
Option A, ma'am.
Option A. Option A is more appropriate or option D is more appropriate? ಯಾವ್ದು ಜಾಸ್ತಿ ಸೂಟ್ ಆಗತ್ತೆ?
Option D, ma'am.
Option D, ma'am.
Option B.
Option A.
A. So, okay, some are saying option A, some are saying option D. Okay, so see here, actually the definition you know, that is dq is equal to du plus dw anta namge gottide. So but the what is the significance of this thermodynamic first law? It is conservation of energy. It gives the idea about the conservation of energy. How the, so it is a form of energy is the more appropriate one. So, but in some books we will get it as a system can do work. In some books we are getting it as a heat is a form of energy. But comparatively, I feel it is heat is a form of energy, we can say, because it gives you idea about the is what it is the conservation of energy concept. Conservation of energy concept ಅನ್ನ ನಮಗೆ ಇದು ಕೊಡೋದ್ರಿಂದ appropriate ಆಗಿ ತಗೋಬಹುದು. Okay. So, but sometimes if option D is not there alla, ಇಲ್ಲಿ ಏನಾದ್ರು option D ಬದಲಾಗಿ ಬೇರೆ ಏನಾದ್ರು ಇದ್ರೆ ನೀವು system can do work ಅಂತ ಕೂಡ choose ಮಾಡಬಹುದು ಅಲ್ಲಿ ಆಯ್ತಾ. ಸೊ ಇಲ್ಲಿ A ಮತ್ತೆ D ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸ್ ಆಗುತ್ತೆ. So compared to these all options, I'll go with option D. Okay, if option D is not there, you can go for option A, no problem. Yes, next one. A thermodynamical system is changed from state P1 V1 to P2 V2 by two different processes. The quantity which will remain same will be. So ಇಲ್ಲಿ ಸಿಸ್ಟಮ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ. ಪ್ರೆಷರ್ P1 ಇಂದ P2 ಗೆ, ವಾಲ್ಯೂಮ್ V1 ಇಂದ V2 ಗೆ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ ಇಲ್ಲಿ. ಆಯ್ತಾ? ದ ಕ್ವಾಂಟಿಟಿ ವಿಚ್ ವಿಲ್ ರಿಮೇನ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಯಾವ ಕ್ವಾಂಟಿಟಿಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ಉಳಿಯುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಆಪ್ಷನ್ ಎ heat, change in heat, change in work done, then change in heat plus work done, then difference of heat and work done. It is D or C, Lohit. Some are saying D, some are saying D. C. Yes. Yes, option C is correct. Here, which quantity will remain same anta ಹೇಳ್ತಿದ್ದಾರೆ ಅವರು, ಹೌದಾ? ಸೊ ನೀವು ಇಲ್ಲಿ ಥರ್ಮೋಡೈನಾಮಿಕ್ ಇಕ್ವೇಶನ್ ಅನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಆಪ್ಷನ್ ಡಿ ಅಂತ ಹೇಳಿದ್ರೆ ಅದು ಬರಲ್ಲ. ಯಾವ ಕ್ವಾಂಟಿಟಿ ಸೇಮ್ ಉಳಿಯುತ್ತೆ ಅಂತಂದ್ರೆ ದ ಎಡಿಷನ್ ಆಫ್ ಕ್ಯೂ ಅಂಡ್ ಡಬ್ಲ್ಯೂ ವಿಲ್ ರಿಮೇನ್ ಸೇಮ್. ದಟ್ ಇಸ್ ಆಪ್ಷನ್ ಸಿ ಇಸ್ ದಿ ಕರೆಕ್ಟ್ ಒನ್. Yes, option C. So here some students are giving Sagar, Bhavani. So there you people are giving option C. The option C is the correct one. Let us go for the next question. In thermodynamic process, 200 joule of heat is given to a gas. So 200 joule of heat is given to a gas, and the Q value. 100 joule of work is also done on heat. So here the work done is 100 joules. The change in internal energy of the gas is. So you need to calculate the change in internal energy. So in the first law of thermodynamics, use the formula, calculate the change in internal energy. Du ಅನ್ನು calculate ಮಾಡಿ. Simple, it is very simple. Yes. Option Q and W value is given. B 300 it will come. Yes.
Option D. 20.
Okay. So in a thermodynamic process, 200 joule of heat is given. Q value. D 24.
Ma'am, your voice is breaking, ma'am.
Remaining students, mute yourself. Don't speak. Even your voice is breaking for me. Just chat, whatever it is there, just chat. You are getting it as 300 or 24. How it is possible? 24, how it is possible? So Q value is there. You have Q value as 200 joules. Yes. Then you are getting it as 300 or 100. Yes. Now all are telling it as AAA. It was till now it was BBB. Now it is AAA. Simple it is. Then why you people are giving it as 300? 300 hag baratte, that is 200 minus 100. It is simple question. Then it is 100. No, it is 100 joule. 100 joule is correct. Deepti, how it will be? 24 hag baratte. 200 minus 100, that is nothing but 100 joules. Simple question it is. This is option A. Let us go for the next question. A perfect gas contained in a cylinder is kept in vacuum. If the cylinder suddenly bursts, then the temperature of the gas. So here what is they are giving? It is a perfect gas in a cylinder which is kept in vacuum, Okay. If the cylinder suddenly bursts, then the temperature of the gas remains constant, becomes zero, increases, decreases.
Option A.
Yes, yes. So here it is option A. Option A, that is the temperature of the gas remains constant. Option A is correct. Then the next question, again based on the first law. If 120 joule of heat is added to a system and the work done of the system is 110 joules, then the change in the again same
40 joule.
Q is, yes, simple one, that is 150 minus 110, that is 40 joules. It is 40 joules. Option D. Yes, Teju, Saumya, it is 40 joules. Pavitra, yes, students, it is 40. Okay, next. Then the next question is, okay, delta Q and delta W represent the heat supplied to the system and burden of the system. Then the first law of thermodynamics can be written as, and delta U is the internal energy. So simple one. It is just direct the formula here. It is A. Yes, it is A. Delta Q is equal to delta U plus delta W. A is correct. Direct the formula. The first law of thermodynamics is option A. The next question is, that is, if for free expansion of is true for free expansion. So for free expansion, what happens? Here the options given as the work done and the change, that is heat is equal to 0, and the internal energy is also equal to 0. Then next here we have, that is delta Q is equal to 0 and W is greater than 0 and internal energy is negative. Work done is 0, Q is greater than 0 and delta Q internal energy is equal to, that is Q. Then work done is greater than 0, then heat is less than 0 and internal energy is equal to 0. Yes, it is A, B, C, D. Yes, Lohit, correct. Other students? It is option D. It is Yeshu and yes, it is option D, that is work done is for a free expansion. Remember this condition. For the free expansion, the work done is greater than 0 and the heat is less than 0 and the internal energy is equal to, change in internal energy is equal to 0. Remember this condition. This is especially the condition for the free expansion of the gas. Okay. Which of the following cannot determine the state of a thermodynamic system? So thermodynamic system idರಲ್ಲಿ ಯಾವುದು ಡಿಫೈನ್ ಮಾಡಲ್ಲ, ಅದು ಏನನ್ನ ಇಲ್ಲಿ ಡಿಫೈನ್ ಮಾಡಲ್ಲ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. That is pressure and volume. That is pressure and volume. Second option is volume and temperature. Third option is temperature and pressure. Fourth option is any one of pressure, temperature. Yes. So see here, by using the thermodynamic system or the thermodynamic laws, we can determine the pressure and pressure, volume, temperature, temperature and pressure. But see here the option D allor in ಹೇಳ್ತಿದ್ರೆ any one of the pressure, volume or temperature. ಅಂದ್ರೆ ನಾವಿಲ್ಲಿ pressure, volume, temperature, pressure ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ಆದ್ರೆ ಯಾವ್ದಾದ್ರು one ಅಂದ್ರೆ independent variable, any one is not possible to calculate. That is option D. That is any one of pressure, volume or temperature is not possible. Yes, that is option D. So single variable cannot determine by using the thermodynamic processes. Then the next question is, which of the following is not a thermodynamic coordinate? Which of the following is not? What is this F option? It is D. Okay. Yes, which of the following is not a thermodynamic coordinate? So option A is pressure, option B is temperature, option C is volume, option D is R, that is universal gas constant. Yes. So it is R, that is option D, R here. So it is not a thermodynamic coordinate. Howda? Thermodynamic coordinate antandre pressure, volume, temperature, work done idellanu barutte. But R, that is your what we can say, that is the universal gas constant, that is not a thermodynamic variable. Okay, option D, R. Then the next question, in a given process for an ideal gas, dW is equal to 0 and dQ is less than 0, then for the gas, the temperature will decrease, the volume will increase, the pressure will remain constant, the temperature will increase. So in condition ಹೇಳ್ತಿದ್ದಾರೆ ನೋಡಿ ಇಲ್ಲಿ, that is dW is equal to 0 ಅಂತಂದ್ರೆ work done is equal to 0. ಮತ್ತೆ ಹೇಳ್ತಿದ್ದಾರೆ, that is the heat is greater, less than 0. Then for the gas, option A, B, B.
The volume will increase.
The volume
decrease.
will increase. Decrease. When the work done is 0 and the heat is less than 0, which means that the temperature will decrease. Yes, option. That is option A, the temperature will decrease. Option A, the temperature will decrease here. Okay. So ಏನಾಗುತ್ತೆ, delta Q less than 0 ಇದ್ದಾಗ ಅಂತಂದ್ರೆ temperature decrease ಆಗತ್ತೆ ಅಂತ ಅರ್ಥ ಅದರದ್ದು. Option A. Shweta, Pavitra, option A is correct. Next question. The specific heat of hydrogen gas at constant pressure is, so Cp value is given 3.4 into 10 raised to 3 calorie per kg degree Celsius per degree Celsius and at constant volume. So Cv value for hydrogen gas is given. Adu 3.4 into 10 raised to 3 anta kottidare matte 2.4 into 10 raised to 3 anta kottidare. If 1 kilogram hydrogen gas is heated from 10 degrees Celsius to 20 degrees Celsius. So ಇಲ್ಲಿ ಏನಂತ ಕೊಡ್ತಿದ್ದಾರೆ ಅವರು ನೆಕ್ಸ್ಟ್ ಅಲ್ಲಿ, ಇಲ್ಲಿ ನೀವು ಹೀಟ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಅನ್ನ. ಟೆಂಪರೇಚರ್ ಎಷ್ಟು ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, 10 ಡಿಗ್ರಿ ಇದೆ ಇನಿಷಿಯಲ್ ಟೆಂಪರೇಚರ್, ಅದನ್ನ ನೀವು ಎಷ್ಟಾಗಿ ಹೀಟ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, 20 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ವರೆಗೂ ಹೀಟ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ಆಯ್ತಾ? The external work done on the gas to maintain it at constant pressure, is work done, you need to calculate. Okay, so let us solve this. Here we know that according to the first law we can write delta Q is equal to delta U plus delta W. Yes, so here the one they are asking, but at two conditions is there. There is Cp, Cv values. So here the work done at constant pressure is equal to, it is delta Q plus minus ಬರುತ್ತೆ, ಬೇಕಂದ್ರೆ ನಾವು work done is equal to we are writing, so therefore delta Q minus delta U. ಹೌದಾ? So but we know that, what we know, that is according to the definition of specific heat, we can write Q is equal to mCp into delta T. Okay. So similarly, we can write delta QV is equal to mCV into delta T. Right. So same way we can write it for delta W at constant volume. The equation becomes, that is, m is common here and Cp minus Cv into delta T Aita. So here the specific heat of hydrogen gases. So hydrogen they have given, therefore I'll take here P minus Cv. Cv is how much? It is 3.4 into 10 raised to 3. Minus Cv is how much? 2.4 into 10 raised to 3. Change in the temperature, 20 minus 10, that is nothing but 10. So simplify this and tell me what you are going to get. I told you the solution part. Okay. Yes. So it is option B, 10 to the power of 4. It is option B, 10 to the power of 4. I hope the solution is clear to everyone. See, if some students are not getting the voice clear, please you change your place and see. Yes, option B. That is 10 to the power of 4. Okay. So Sagar is asking to explain once again. So see here, that is according to the first law of thermodynamics, we can write it as delta Q is equal to delta U plus delta W. ಆಯ್ತಾ? So ಈ equation ಅಲ್ಲಿ delta W ಅನ್ನ ತಗೊಂಡ್ರೆ ಏನ್ ಬರುತ್ತೆ? Delta W is equal to delta Q minus delta U. The difference of the heat, the change in the internal energy. ನಮಗೆ ಗೊತ್ತಿದೆ, ಏನ್ ಗೊತ್ತಿದೆ? According to the definition of specific heat capacity, we know that Q is equal to mc delta T ಅಥವಾ ms delta T ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ. ಕೆಲವೊಂದು ಬುಕ್ ಅಲ್ಲಿ ಎಸ್ ಇದೆ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್, ಕೆಲವೊಂದು ಬುಕ್ ನಾವು ಸಿ ನೋಡ್ತೀವಿ. Constant pressure and constant pressure and constant volume, the equation how we can write it as Q is equal to m. For constant pressure I'll write it as Cp delta T. Okay, so for constant volume I'll write it as Q is equal to m into Cv delta T. Yes. So here I am taking the difference of I'm taking the difference of these two. So if I take the difference of these two, here m common agi barutte. If you take m common here, then Cp minus Cv into delta T. So m is 1, Cp minus Cv, whatever value we have taken, into delta T is, if you substitute everything, we will get as option B. Option B is correct here. question. Hope so clear. Clear now? The next is which of following parameters does not characterize the thermodynamic state of matter. So, it is not a thermodynamic of matter. Volume, temperature, pressure, and yes, this question is repeated. See that. Then the next question is, in a thermodynamic system, in a thermodynamic system, working substance is ideal gas. Okay, the internal energy of the internal energy is in the form of, yes, in a thermal system, the working gas is mute self is that Radha Kattimani. Okay, in a thermodynamic system, the working substance is ideal gas. Its internal energy is in the form of kinetic energy only, kinetic and potential energy, none of these. So internal energy definition ನಾವು ಹಿಂದೆ ಮಾಡಿದ್ವಿ ಹೌದಾ. So internal energy is what? ಯಾವ್ದು ಬರುತ್ತೆ? What is the answer? Yes. Here the internal energy is always the sum of kinetic energy and potential energy. How that? So internal energy is the form of that is kinetic and potential energy. Is option B is right here. I hope the voice is clear now. Is the option B kinetic and potential energy. B is next question. Which of the following statement is correct for in thermodynamics? What is the answer? Which of the following statement is correct for any thermodynamic system? The internal energy changes in all processes. Internal energy and entropy are state function. The change in entropy can never be zero. The one in an adiabatic process is always zero. Which one is correct? Which of the following statement is correct? C. The internal energy changes in all processes. Internal energy and entropy are a state function. The change in entropy can never be zero. work done in an adiabatic process is always 0. So everybody is giving one answer, A, B, C, D.
Option D, the work done with an adiabatic process in always 0.
Yes, that is what is the option B is, that is internal energy and the are state functions. So if you read the option, you correct it, but internal energy changes in all the processes. This is not true. For some processes, the internal energy remains constant here. Okay. So here the internal and entropy are state function. That is the appropriate answer for the given question. Then the next question is, so this is the last question for thermodynamics. Next, we are going to proceed with adiabatic. The heat as 200 and the work done as 40. But see here, the heat is given in terms of calorie. How the heat and calorie ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು. So what you need to do, you need to convert that heat calorie into joules. So how we are going to do that? That is, see this one. Here we will take it as delta Q is equal to delta U plus delta W. Okay. Therefore, here delta Q is 200, but it is given in calorie. Therefore, convert it in terms of joules is equal to delta U calculate ಮಾಡಬೇಕಿದೆ, delta W ಎಷ್ಟಿದೆ 40 ಇದೆ. So 200 into 0.4, sorry 4.2 minus 40. What is the answer? What is the answer here? Yes. Remaining students. Yes. Option B. Correct here is nothing but what? It is decreases by 800. It is decreasing by 800 joules. Here the option B is correct. B is correct. Now let us go for. Now let us go for the adiabatic process of the questions. Yesterday we have covered some 5 questions. So let us see the questions. Okay, this was yesterday's last question. Gas at NTP suddenly compressed to 1/4 of its original volume. If gamma is supposed to be 3/2, then the final pressure is. So we have discussed this question. So it is the option C and ಬಂದಿತ್ತು. I hope you people have done this one. So I'm going to continue with the next question. That is monatomic gas. Monatomic gas ಅಂತಂದ್ರೆ gamma value ಎಷ್ಟು ಬರುತ್ತೆ 5/, which is given in the question. Is suddenly compressed to 1/8 of its original volume adiabatically. Then the pressure of the gas will change to. The pressure of the gas will change to. Yes. So question is displayed. Try yourself. How we are going to do this one? That is, check. Cp by Cv is equal to adiabatic process. ಇದು adiabatic process ಇದೆ. So in case of adiabatic process, PV raised to gamma ಅಂತ ತಗೊಂಡು ನೀವು ಮಾಡಬಹುದು. Anybody is getting the answer? So how do I simplify this? That is, we have the gamma value as 5/3 given in the question. That is P1 V1 raised to gamma is equal to P2 V2 raised to gamma. So P2 divided by P1 is equal to V1 divided by V2 gamma. Okay. So therefore, P2 by P1, it is compressed to the volume of 1/8. ಅಂತಂದ್ರೆ 8/1. Volume is compressed. So to the power of how much it is? 5/3. So if yes, what is the answer? Yes, Lohit, very good. That is option D, 32 times. Everyone understood? Should I repeat it, or you people have understood the solution? Yes? Repeat. Okay. See here, according to the thermodynamic equation, it is given by PV raised to gamma, which means that P1 V1 raised to gamma is equal to P2 V2 raised to gamma. So what they are asking then, pressure of the gas will change to ಅಂತಂದ್ರೆ P2 divided by P1 they are asking. So which is equal to P2 by P1 is equal to ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ V1 divided by V2 raised to gamma. Okay. So see here, it is suddenly compressed to 1/8 of its original volume. It is suddenly compressed to 1/8 of its original volume, right? So here, if you consider the initial volume as V, V2 will be 1/8 of that. V2 will be 1/8 of that. ಆಯ್ತಾ? So V2 will be 1/8 of that ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ? ನೀವು ಇದನ್ನ simplify ಮಾಡಿದಾಗ can I write it like this? It will become 8 divided by 1. Gamma value ಕೊಟ್ಟಿದ್ದಾರೆ question ಅಲ್ಲಿ. What is the gamma value here? That is 5/3. ಹೌದಾ? So what is this? 8 to the power of 5/3. 8 to the power of 5/3. Yes. It is nothing but 32 times of its initial pressure. So here, this is equal to 32 of P1, which means your pressure P2 is 32 times of the initial pressure P1. Is it clear now? I hope the voice is clear and the solution is also clear to you. Option D. Yes, both are clear. Okay, done. Let us go to the next question. The pressure and density of a diatomic gas. So diatomic gas alli gamma value est kottare, that is 7/5. Change adiabatically from PD to P dash D dash if D dash by D is equal to 32. Andre density ratio kottidare 32 anta. Then P dash by P should be. P dash by P should be. So how to do this one? Again, take the adiabatic equation. So all the questions are based on adiabatic equation here, right? Therefore, PV raised to gamma is equal to constant. PV raised to gamma is equal to constant. Then next, in terms of density we require. So therefore, I'll make this equation as P into gamma, sorry, rho, that is density raised to gamma is equal to constant. Therefore, same equation ಮೊದಲೇನು ಬರ್ದಿದ್ರಿಯಲ್ಲ ಅದನ್ನೇ, but in terms of density we are taking now, not in terms of volume. It is rho1 divided by rho2 to the power of minus gamma, because here minus will come. Volume du PV raised to gamma anta baratte. Density tagondaga gamma, density in terms of density it is P into rho raised to minus gamma. So therefore this density ratio, what they are giving you, the density ratio as 32. ಹೌದಾ, D2 by D1 ಕೊಟ್ಟಿದ್ದಾರಲ್ಲಿ, ನಮ್ಗೆ ಇಲ್ಲಿ ಏನ್ ಬೇಕಾಗಿದೆ D1 by D2. Therefore it will be 1 upon 32. It is 1 upon 32 to the power of minus 7/5. So if I simplify this, it will be 32 to the power of 7/5. So what is the answer here? It is nothing but 128. It is nothing but 128. Yes. Option C is correct. Is it clear, students? Yes, option C. Yes, okay. Let us go for the next question. Okay, an ideal gas at 27 degrees Celsius is compressed adiabatically to 8 by 27 of original volume. If gamma is equal to 5/3, then rise in the temperature is. Yes. So idrikinta munche neeven question nodidri? That is, you have seen by using pressure and volume. Now the relation is for what? Temperature and the volume. How the, so here, how we are going to get it? That is nothing but based on temperature and volume, the equation is PV raised to gamma minus 1 is equal to constant. Right? Therefore, T1 divided by T2 is equal to V2 divided by V1 to the power of gamma minus 1. Yes. So volume they are giving you as 8 by 27 to the power of 5/3 minus 1. So 5/3 minus 1 andre estagutte? It is nothing but 2/3. Howda? So therefore this is equal to 8 divided by 27 to the power of 2 by 3. Now T1 ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ ನೋಡಲ್ಲಿ, that is 27 degree Celsius ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಹೌದಾ? So if it is 27 degree Celsius in terms of Kelvin, it is 300 Kelvin, right? Substitute T1 value as 300 upon T2, which is equal to, so 8 by 27 to the power of 2 by 3, it is nothing but 4 by 9. So I require only T2, therefore T2 is equal to 300 into 9 by 4. So what is the answer? Option B. Okay, yes. So here we are going to get it as 675 Kelvin. Howda? So it is 675 Kelvin, but the T2 value, we are going to make it as 675 minus 300. Therefore, the T2 temperature is how much? It is 375 Kelvin. It is 375 Kelvin. Yes. Shweta, Nandish. Yes. So this is option B is correct here. Option B is correct. So let us go for the next question now. Two identical samples of a gas are allowed to expand isothermally and adiabatically. Work done is more in the isothermal process, more in the adiabatic process, neither of them, equal in both process. Yes. So if you see the slope or the graph of this as isothermal and the adiabatic process in terms of PV graph, so the graph is somewhat like this. So here it will come in this way. This curve is for the isothermal process and this curve is for the adiabatic process. So according to the graph, can you answer now? Yes, it is option A. It is more for the isothermal, more in the isothermal. The work done is more in the isothermal. So based on the graph, you can say this one, and it is PV diagram. Idu pressure versus y-axis, volume axis. Option A. Yes, Deepali, Lohit. Yes, it is correct. Option A is right here. Next question. Which of the statement is right? Again, check. So which is a correct statement here? For an isothermal change, PV is equal to constant. In an isothermal process, the change in internal energy must be equal to the work done. For an adiabatic change, P2 by P1 is equal to V2 by V1 raised to gamma, where gamma is the ratio of specific heats. Option D, in an adiabatic process, work done must be equal to the heat entering the system. Okay, which of the following statement is correct? So see ಹೇಗೆ ಬರುತ್ತೆ, if you change the equation, see the equation is what? P1 V1 is equal to P2 V2 raised to gamma. ಹೌದಾ? ಸೊ ನೀವು ಅದನ್ನ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಇಕ್ವೇಶನ್ ಅನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಅದು P1 V1 is equal to P2 V2 raised to gamma ಅಂತ ಬರುತ್ತಾ? ಬರಲ್ಲ. ಎಸ್ ಎಸ್ ನಂದೀಶ್, Kumar, Shweta, A is correct. Here A is correct. That is the isothermal change. PV is equal to constant. That is correct. C ಬರಲ್ಲ, ಯಾಕಂತಂದ್ರೆ ನೀವು ಇಕ್ವೇಶನ್ ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ P1 V1 raised to gamma is equal to P2 V2 raised to gamma ಅಂತ ಸಿಂಪ್ಲಿಫೈ ಆಗಲ್ಲ ಅದು. So see the question properly. That is, for an isothermal change, PV is equal to constant. That is correct here. Option A is the right one. Okay. So the last question for is that slope isothermal and adiabatic curves are related as isothermal curve is equal to adiabatic curve slope. Isothermal curve slope is equal to gamma into adiabatic curve. Adiabatic curve slope is equal to gamma into isothermal curve. Adiabatic curve is equal to 1 by 2 isothermal curve slope. Yes. So more theory based questions we will get from the thermodynamics. I thought. Yes, Lohit. Pavitra. Correct. Option C is correct here. See, if you want the solution, I can give you. Option C is right. ಸೊ ನೀವು ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕಾಗತ್ತಂತಂದ್ರೆ ಎರಡು ಪ್ರೊಸೆಸ್ ಯಾವ್ದೆರಡು ಪ್ರೊಸೆಸ್ ಐಸೋಥರ್ಮಲ್ ಮತ್ತೆ ಅಡಿಯಾಬೆಟಿಕ್ ಪ್ರೊಸೆಸ್ ಸ್ಲೋಪ್ ತೆಗಿಬೇಕಾಗತ್ತೆ. ಹೇಗ್ ಮಾಡ್ತೀರಾ? ದಟ್ ಅಡಿಯಾಬೆಟಿಕ್ ಐಸೋಥರ್ಮಲ್ ಪ್ರೊಸೆಸ್ ಅಲ್ಲಿ ಪಿ ಬಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ಇದೆ, ಹೌದಾ? ಇಫ್ ಯು ಅಪ್ಲೈ ದ ಲಾಗ್ ಇಟ್ ವಿಲ್ ಬಿ ಲಾಗ್ ಪಿ ಪ್ಲಸ್ ಲಾಗ್ ವಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಕಾನ್ಸ್ಟೆಂಟ್, ರೈಟ್? ಸೊ therefore ಲಾಗ್ ಪಿ ವರ್ಸಸ್ ಲಾಗ್ ವಿ ಗ್ರಾಫ್ ಅಲ್ಲಿ ಅದು in case of PV is to gamma ದಲ್ಲಿ ಏನಾಗುತ್ತೆ? log P plus gamma log V is equal to log K. Prove that one. Again proof ಬೇಕಾಗಿಲ್ಲ. So ನೀವು will just remember ಮಾಡ್ಕೊಳ್ಳಿ. That is option C is correct. Adiabatic curve slope is equal to gamma into isothermal curve. Okay. Option C is correct. So question I'll give you as a homework. You can check this. So you can simplify it later. Pressure temperature relationship for an ideal gas undergoing a change. Gamma is equal to Cp by Cv. So this you can check it out. Or else if you know now also you can tell the answer. Pressure temperature relationship for an ideal gas undergoing adiabatic change. Yourself. Okay, students. So here only we will stop. In the next class, we will discuss the next lesson. Okay. So thank you. Have a good day.
Thank you, ma'am.
Thank you, ma'am.